Welcome back to another video. In this episode, we are going to look at how we can prove this particular theorem or this particular property. This is basically a property in linear algebra. Okay, so basically in matrices as well. So here we want to prove that if you have a matrix A and another matrix B, they are non-singular matrices. Okay, now, the product of the matrices, okay, is non-singular. So we want to show that this given statement, AB inverse is equal to B inverse A inverse. So first, what you have to understand is that before an inverse can exist, then the determinant must not be equal to 0. Once the determinant is equal to 0, you can't have an inverse to exist. So the inverse must exist when you have the determinant not to be equal to 0, or when you have a non-singular matrix or an invertible matrix. Okay, so what I want you to recall is that there is this, if you have a matrix M, right? When you have a matrix M, okay, and you multiply it by the inverse of the matrix, okay, then this is the same as matrix inverse, the M inverse times the matrix, and this is equal to the identity matrix. The I here is basically the identity. You know, this and this basically becomes roughly identity, and this too is an identity. So this and this is equal to this, and that is equal to an identity matrix. So basically, we are going to prove that AB or inverse is equal to B inverse A inverse. Okay, so we are going to apply the associativity property. Okay, so you know that associativity holds in matrices, or in matrix multiplication, associativity property holds. Okay, so we want to show that first, before this property can hold, then when you take the product of the matrices, okay, when you take the product of the matrices times, okay, times their inverse, okay, times their inverse, this should be equal to an identity matrix. So let's say this is equation 1. So this, you take the product of the matrices, the times the inverse of the second matrix times the inverse of the first matrix should give you an identity matrix. 2, when you take the opposite, B inverse, A inverse, times their products, okay, times the product of the matrices should give you an identity matrix. And this is equation 2. So for this equation to hold, this and this must be valid for us to conclude that indeed, this right here is equal to this. Don't forget this property. You're going to use it very, very well. So let's consider the first equation, okay? Let's consider the first equation. So once we do for the first equation and do for the second equation and both holds, then we can conclude that this statement is good. Okay, so let's consider the first equation. So we are going to have A, AB, B inverse is equal to an identity matrix. So this is where we apply the associativity property, the multiplication, associativity in multiplication. Okay, basically that is when you try to multiply a matrix, 3 matrices, that is associativity in multiplication. Anyway, you call it. Okay, so we are going to consider this to check if it will give us an identity matrix. So guess what? What are we going to do here? Guess what we are going to do? Can you pause the video and do it, check it, and see if you are on track? right? So using the associativity of matrix multiplication, we group the terms, we can group these terms, right? We can group these terms as A, out, as A out, then we have B inverse, B inverse. Then we have A inverse outside. That is associativity in matrix multiplication. Okay, so once we have this, then something has to come off head from here. Okay, something has to come off head. You know that when you have a matrix multiplied by its inverse, it gives you an identity matrix. So we're going to apply that here. So we're going to have A into I times A inverse, and that is equal to I. Okay, but don't forget that when you multiply an identity matrix with any matrix, you're going to result in the same matrix. Okay, so here we're going to have A inverse, and that is equal to I. Don't forget again, that this is basically I. So this is basically I. So you can see that I is given as I. So we can say that I is equal to I. And this has proven our first equation. So this has proven the first equation. So the first equation is satisfied. So we go ahead to consider the second equation as well and check if it will satisfy this particular condition. Okay, let's go. So okay, we can do it here. So B inverse A inverse times the product of A and B should be equal to an identity matrix. Okay, so as usual, we're going to apply the associativity property in matrix multiplication. So we are going to apply the same knowledge in here. Okay, so once we have this and we know the associativity property in matrix multiplication, we go straight to it. So we have to change the position of the terms as we did right here. So let's do that. Okay, so now we use what we call the associativity property as mentioned earlier. So associativity property, okay, again, so we group these terms as B inverse outside, then into A inverse A, inverse A. Then you have your B right here, and that should be equal to an identity matrix. Very interesting. So here, you know that this is, of course, I. So you have B inverse into I times the matrix B. Okay, so once you know that when you multiply any matrix by an identity matrix, that is then the shape of the matrix. So we don't care about this I here. So what we're going to do here, is going to be B inverse. You know, this goes off. So you have B inverse times B, and that is equal to I. So since we know that B inverse B is equal to I, then we can say that our I is equal to I. Hence, we have proven the second condition as well. So basically, that is the process that involves when you want to prove this kind of given statement. Okay, so once we have this, then we can say that since the first condition and the second condition holds, we can say that this means that B inverse A inverse is indeed the inverse of AB. B inverse and A inverse is indeed the inverse of AB. So basically, that proves our property or our theorem. Ladies and gentlemen, thank you very much. I really appreciate your time. Don't forget to subscribe, share with your mate, and I'm going to give you more updates. Bye bye.